Yes, hi guys. Today I will talk about what are the what is the integration of transcendental functions. I've defined what are the transcendental functions. Now transcendental functions are those functions which are not algebraic, other than algebraic functions or already we have up now discussed that integration of irrational algebraic functions. Okay, so algebraic functions, the functions which are not algebraic are known as transcendental functions. These transcendental functions are like trigonometric functions, inverse trigonometric functions, logarithm functions, okay, exponential functions, and hyperbolic trigonometric functions, or inverse hyperbolic functions. All those functions are known as transcendental. These are some examples of transcendental functions. Okay, transcendental functions. Today I have to talk about what are transcendental functions. First of all, I'll talk about trigonometric transcendental functions. So trigonometric transcendental functions, okay, which are not algebraic. So we will talk about them. But first of all, let me define that what is the topic of today. Topic of today is integration of transcendental functions. Now integration of transcendental functions. Now what are the transcendental functions? I defined it already in the beginning, and I started differential calculus. In those days, I defined what are the functions. Then different kind of functions are defined. Okay. So non-algebraic functions are known as transcendental functions. These transcendental functions, let me define them. What are transcendental functions? Okay, so transcendental functions are, first of all, transcendental functions, let me define. Transcendental functions, what are these? And then today's topic, which is trigonometric functions. And what kind of trigonometric? There are different kind of trigonometric functions and various, layers of this that I'll talk about one by one. But today I'm talking about when the powers of trigonometric functions are odd functions. Okay, and odd number power is given to trigonometric functions like sine theta, or sine x, cos x, tan x. Okay, to all these six trigonometric functions. Trigonometry like so, sin x, cosecant x, tan x, cotangent x, then cos x and secant x. Okay, these six are known as trigonometric functions, and these trigonometric functions and their powers, if are given as odd numbers, then what are the integration of them? How integrate them? That I'll define today. Now questions are based on all this kind of odd powers are given to these trigonometric functions. That I have to define that how to integrate them. Taking some okay instances here. First of all, let me define what the transcendental functions. Let me define. Okay, a function or a series like let me talk about. If I talk that this is p naught x, if I take this is y raised power n plus this is p1 into x. Here p1 x, p naught x are the functions which are functions of x. Algebraic functions are of x, of variable x. P naught x is an algebraic function expressed in terms of x. Expressed in terms of x. P naught x, p1 x, etc. This is yn minus 1 plus p2 into x, yn minus 2, etc. Plus and so on. And last, let me talk about this pn minus 1 into x into y plus this is p 0 here. This is p0 I have taken. This is pn here. This is n minus 1. This is pn and y raised power n. Pn x and y raised power n. Okay. This is what we have. Sorry, y raised power 0. That means 1 only. That means this is only pn x. This is pn x only. Let me write it as proper way. In proper way, it is nothing but pn x. Okay, so this is here this kind of function, which is algebraic function here. So here, let me talk about p naught x, okay, p1 x, etc., and pn x are algebraic functions or are algebraic expressions or polynomials. Algebraic polynomials, we will say. This is a polynomials expressing variable x. Okay. This kind of function is known as algebraic function. So this is an algebraic expression. This is known as an algebraic expression or algebraic function or algebraic function or algebraic function. Now, all those functions which are not in the which are other than the expression of this kind of function, which are all those functions which are not of the error form. Okay, error form means this. Let me take this first equation of error form of equation 1 are known as transcendental functions. So they are known as transcendental functions. They are known as transcendental functions. Okay, so they are known as transcendental functions. What are the transcendental functions? Let me now define. Transcendental functions, therefore, the following sum of the functions are known as transcendental functions, right? Are known as transcendental functions. Are known as transcendental functions. Yeah. For example, let me take for instance trigonometric functions. Trigonometric functions are transcendental functions. Like if f(x), the function given as sin x, cos x, tan x, etc. They are known as trigonometric functions. They are also transcendental functions. Then second type, if I take inverse trigonometric functions, okay, like if f(x) equal to sin inverse x, cos inverse x, tan inverse x, etc. All these transcendental functions are. Then let me take the third one as exponential functions. They are also known as transcendental functions. Exponential functions. What are these exponential functions? Like a raised power x, okay, then any constant value like 2 raised power x, etc. are known as exponential functions. Are exponential functions. Now let me take fourth one. Logarithmic functions. Logarithmic functions like log of x, right? Log of 1 plus x, etc. Twice log of x, anything, etc. They are known as logarithmic functions. Alright, then if I take fifth one, hyperbolic functions. Hyperbolic functions. Trigonometric hyperbolic functions. These are known as hyperbolic functions. Okay, if fx equal to let sine hyperbolic x, cos hyperbolic x, tan hyperbolic x, etc. All these are known as hyperbolic functions. If fx equal to log x, okay, these are exponential logarithmic functions. Exponential functions are ax, ex, etc. Then sixth one, which have to take inverse hyperbolic function. Sixth one is let me take inverse hyperbolic functions. Inverse hyperbolic functions. They are also known as okay, transcendental functions, like if fx equal to let me take sine hyperbolic inverse x, cos hyperbolic inverse x, let me take here cos hyperbolic inverse x, tan hyperbolic inverse x, etc. All these are known as transcendental functions. Okay, so we have defined now what is a transcendental functions. Now let me take today's topic is trigonometric functions. Let me take from the beginning. So what is the integration of trigonometric functions? Now we are talking about first series of this whole transcendental functions. Now let me take one by one. Transcendental function. Now let me take trigonometric functions first. Transcendental functions. First let me take trigonometric functions first. So now let me take integration of trigonometric functions. What are those? Sorry. Trigonometric functions first and foremost. Now trigonometric functions. Trigonometric functions. Today I have to talk about. So there are a number of type of functions. Today I am taking case number 1. There are different cases here. Case number 1 or type 1, you may say. Type 1 of trigonometric functions. Type 1 here. Now in this case, let me take 1. If powers of sine x cos x are given, if powers of sine x cos x are all positive integers or positive integers. Like you have to find out what is integration of sine nx dx. Kind of integration cos of, let me take nx into dx, or here let me take mx. You have to take here, this is mx, let me take. Okay, so etc. These kind of what is sin x and cos x, these functions let me take. So what is the integration of sine nx and cos nx? Yeah, n and m are all positive integers. This is the first thing we are talking about. So if let me take first sine nx. In this case, integration of sine nx, sine n into x, when n is equal to, let me take twice m plus 1, where m is a positive integer. Positive integer. M is a positive integer, and twice m plus 1 will be an odd number. If I take suppose m equal to 1, this is 2 plus 1, 3, m equal to 2, then 2 plus 2 into 2, 4 plus 1, 5, odd numbers. So n is an odd number. Then what is the integration of this kind? Where m is an integer. In this situation, what is the integration of sine nx? How to integrate this? Therefore, in this case or such cases, in such cases, we express that sine is power. This is sine is power twice m plus 1 into x into dx. We have taken the power is twice m. Okay. Power is twice m plus 1. We express this as sine raised to twice m separately into sine x into dx. Now what we do, we write here sine square x whole power n into sine x into dx. What we do now, we express sine square x as 1 minus cos square x whole power n into sine x into dx. Now we substitute something. Now what we substitute? After that we substitute, or in this case we substitute now, substitute or substitution. What we substitute here? That inside value the bracket value, let cos x equal to t, differentiating it with respect to t, differentiating it with respect to t. So we get here minus sine x differentiation into dx upon dt equal to 1, or minus sine x dx equal to dt, or sine x into dx equal to minus dt. So we substitute here, let me write in this case, this is minus sine 1 minus cos means here, because cos x we have taken t, t square whole power n into dt. Why? Because sin x into dx equal to dt. Now it is to be integrated. Now the integration of this will be by binomial expression. First we have to express this by binomial theorem, okay, or binomial expression, then integrate each term of this. Okay. So finally what we do, we express this by the binomial expression. Now this is to be expressed. Now 1 minus t square whole power n is to be expressed by binomial theorem. By binomial theorem, and each term then is integrated separately. Is integrated and answer is found. And that will be the final answer. And that will be the final integration. Final integration. Now it can be integrated easily. That will be final integration. This is the process. First we have to express 1 minus t square whole power n by binomial expression. Okay, so first will be 1, then minus m into t raised power t2 only, because 1 raised power m minus 1 is only 1, and this 1 raised power m is 1. So first is 1 minus m into t square, then plus sign, because this is odd function. If it is 1 minus sign and here it is plus sign, so if it is odd, minus plus. By binomial expression we write alternate negative positive, first positive then negative, then positive then negative, this way. And the final term, the last term, may be positive or negative. We substitute then minus 1 raised power n. Here it is m. Whatever the power n, if it is odd number, then last term will be minus. If it is even number, then last term will be positive. Okay, so that is how we express this by binomial expression, then integrate each term. Okay, by integration process. This is how we have to integrate. This is integration process for odd functions of sine. Now let me talk about what is odd functions of cos. So integration of now cos raised power n. Okay, now let me talk about cos raised power n. So integration of cos raised power, let me take m x into dx. Here also m is equal to twice r plus 1, let me take. Here r is a positive integer, so it will be an odd number. It is a positive integer. Okay, so therefore m will be an odd number, because r, if you say 1, 2, 3 and so on, positive integer, and will be okay, then what will be is an integer, even if it is negative positive, but we have to express this. If it is positive integer, then it's coming at positive numbers like that. Okay, positive integers plus. So then we can express this by binomial expression the same way. Now let me write it as this cos or y star plus 1 into dx, x into dx of x. This is now this can be again expressed as cos 2 into 2r into x into cos x. This is cos of 2r into cos x for the one power here that we have separated. Now again, this can be expressed as cos square x whole power n, r. This is r into cos x dx. Further, cos square x is nothing but 1 minus sin square x whole power r into cos of x into dx. Okay, now sin x is to be substituted. So next substitution is, what is substitution here? Substitution is putting sin x equal to t, differentiating it with respect to t, differentiating it with respect to t, we get here, this is cos x, okay, into dx upon dt is equal to 1, or cos x dx equal to dt. This is here cos x dx dt. Finally, we obtain this one. Sorry, this is 1 minus t square whole power r into dt. Again, it can be expressed by binomial expression and it can be integrated finally. Now this can be again. Now 1 minus t square whole power r can be expressed by binomial theorem or using binomial theorem. By binomial theorem or using binomial theorem. Okay, using binomial theorem, and then it can be integrated. Then it can be integrated. Each term can be integrated in the same process. So this is the process of integration of trigonometry. Okay, so let me take these questions now. Now again, these questions are taken from students' queries. So please just pay attention towards how to integrate them. If there is any process line which is not understood, then for sure solve this. I think trigonometric functions are easy to know some basic of trigonometry, then they can get the integration of them. Now let me take this transcendental function of trigonometric functions. And let me solve this all these questions now. What are the questions here? Let me take first question. Okay, so this first question I have expressed. I've just done question number 1. I have done sin nx dx where n is equal to s n plus 1, but n is a positive integer. Then we have already expressed. I'm sorry. So now let me take second question. Question number 2. This is numerical value sin 7x dx. It can be expressed as, let me express this, sin 6x into sin x into dx. Now it can be expressed as sin square x whole power 3 into sin x into dx. Now expressing sin square x, that will be 1 minus cos square x whole power 3 into sin x into dx. Okay, substitution here first, cos x as equal to t, differentiating it with respect to t now, differentiating it with respect to t. So we get finally, what do we get here? Minus sin x into dx upon dt equal to 1, or minus sin x dx equal to dt, or sin x into dx equal to minus dt. Alright, so minus dt we have to substitute here. This is sine of integration 1 minus t square whole cube into minus sign that we take out, and it is dt. So minus dt. So I put here minus sign out of sine of integration. Okay, and that will be 1 minus t square whole cube into dt. This is, let me express this now by whole cube binomial expression. This is also an expression. Now it will be 1 minus t raised to the power 6, the negative sign, minus 3 into, first will be, let me write here t square within bracket. Okay, this is sine of integration here, which I am not integrating. Now this is 1 minus t square, minus sign in between, minus 3 into a into b, or 3 into this will be minus 3t square. Okay, then into dt. Whole cube is expressed like this. Now let me further resolve it. This is 1 minus t6 or 3t is 6. Okay, so now this is to be expressed as minus 3t square plus sine. This is 3 into t4 into dt. Now which term can you integrate? Now integration either write them separately. Let me write separate. This is first dt minus minus plus here. Minus sign by there. This is sine of integration t raised to 6 dt minus plus again. Sine of integration, this is 3 into t square into dt minus sine 3 into sine of integration t4 into dt. Okay, this is, let me take final answer. This is minus t plus this is t 7 upon 7 plus sine 3 into dt upon 3 minus sine 3t4, well, I'm sorry, 5 upon 5 upon 5 odd numbers plus constant of integration will be right here, because this is indefinite, not indefinite integral. This is, now let me take what is the next point. Value substituting, putting the value of t now. T was cos x. What is the final answer? Therefore, final answer will be here. First is minus cos x. Of t is minus cos x. T is cos x, we are substituting. Plus sine 1 upon 7 into cos power 7x. 3 cancel out. This is plus sine cos of cube x minus sine 3 upon 5 cos of 5x power 5 plus constant of integration. Okay, or we can write them in either decreasing order or increasing order. If I write them in increasing order, then first is cos x, then highest power is this, and plus cos of qx, and highest power is this, minus 3 upon 5 cos of 5x. This is in increasing order, plus or in ascending order. Okay, in ascending order. So this is 1.7 cos raised to 7x plus constancy. This is the final answer. This is question number 2 we have done. Question number second I have done. Now let me have this. Now let me take the third question. So what's the question number third? Let us talk about. So question number third. What is the question number third say? Let me talk about that. Question number third. Here is sine of integration. What is sine of integration here? Third question, sine cube x. This is sine of cube x into dx. The 7x are taken. So again, putting it as simple question, sine square x into sine x, or divided into two parts. This is equal to nothing but 1 minus cos square x into sine x into dx. Because as since sine square x equal to 1 minus cos square x, If you know from first trigonometric identity, sin square theta plus cos square theta is equal to 1. This we have used here. Let me substituting cos x equal to t. So minus, let me write directly cos x dx equal to dt, or cos x into dx. What I'm doing, I'm sorry, this is sin x. Cos x direction is minus sign I have substituted, but not writing properly. This is sin x into dx equal to, I'm sorry for this, but this is cos x differentiated minus sin x, and sin x has positive cos x differentiation. So that is vice versa in integration. But in case of differentiation, cos x is negative sin x. It is sin x dx into minus dt. Finally, we have obtained minus sign. This is 1 minus t square into dt. Integration now, let me write directly. 1 integration is t minus plus here plus t square integrated t to the power 3 plus constant of integration. Now we have to substitute the value of t. T is cos x here minus cos x plus 1.3 cos of 2x plus c constant. This is the answer. Final answer is this. Question number 3rd we have done. Okay, so this is the process of integration of trigonometric functions, mostly of sine of all power. Okay, let's now even powers we will take when both m and n are given even powers. That we will take a reduction formula. Okay, when sin x and cos x are multiplied in sin nx cos nx, powers are n and n solution. Which is sin n power x plus cos power n x. They are in even powers. If m and n both are even integers, then what the process? If in that situation, we have to do the next process. But before that, let me take this all these questions one by one. So this is now 4th question. Sign of integration is now sine 5x. Again the same process. This is sine of 4x, sine of x is 5x. Okay. Now again substituting, this is nothing but sine square x whole square. That means 1 minus cos square x with sine square x equal to whole square sine x into ds. Putting again that cos x equal to t. Putting or substituting cos x equal to t. Differentiating it with